Hi there, and welcome to this web lecture on behavioral research methods. My name is Peter Ruiten, and today we will be talking about power and precision. Did you know that researchers can make two different types of errors? What is the difference between statistical significance and practical significance? What is this magical p-value that researchers always report? In this lecture, we will discuss the following four concepts. We will first talk about power. Then I will say something about the p-value. Next, I will explain what statistical significance is. And finally, I will show you different measures of effect size. Let's start with power. Power is a probability of detecting an effect if it exists. This means that if you have a high power and you find an effect, you can be very certain that this effect exists in reality. This probability is very much related to another probability, the p-value. P-value can be defined as follows. It is the probability of detecting an effect assuming that your null hypothesis is true. This is an important aspect of so-called null hypothesis significance testing. In this method, there are two different types of hypotheses, null hypothesis and alternative hypothesis. The null hypothesis states that there is a default statement that there is no relation between two different variables. The alternative hypothesis states that the expectation that a difference between a variable exists. This is also called the researcher hypothesis. Let's look at different consequences of finding an effect in the case whether or not it exists. On the left side of the table, we see whether our test shows an effect or not. On the top of the table, we see whether this effect exists in reality or not. There are four possible outcomes of this study. The first is when the outcome of our test shows an effect, while this indeed exists in real life. In this case, we are correct. The second one is when the outcome of our test shows an effect, but in reality, this effect does not exist. In this case, we make a so-called type 1 error. We always allow for a type 1 error to happen by deciding on a so-called alpha level. The higher this alpha, the higher the probability of making a type 1 error. This alpha level is usually put at 0.05. The third option is when our test shows no effect, while in reality there is an effect. In this case, we make a so-called type 2 error. We also allow for this type 2 error to happen by deciding on the power of our test. The probability of this type 2 error to occur is 1 minus the power of our study. The final result is when our test shows no effect and there is indeed no effect in reality. In this case, we are again correct. Whether or not a test shows an effect is determined by statistical significance. Statistical significance indicates a result that shows that it is very unlikely that your null hypothesis is true. There is an important difference between statistical significance and practical significance. Statistical significance occurs when your p-value is lower than your alpha value. Practical significance states that some small differences could be meaningless. Imagine you find a very small effect in a very controlled laboratory setting. Maybe this effect is statistically significant, but it doesn't make any practical use. One way of assessing practical significance is by looking at so-called confidence intervals. A confidence interval estimates the probability that a population parameter will fall within a certain range. Usually we make use of 95% confidence intervals. Another way of assessing practical significance is by looking at effect sizes. An effect size is a metric of this practical significance or a magnitude of relationship between two variables. We categorize between three different types of effect size. These are the Cohen's d, an odds ratio and a correlation. A Cohen's d shows a standardized difference between means. Usually we use this when we make use of continuous data. The odds ratio shows a relationship between two binary variables. So here we make use of categorical data. A correlation is a measure for non-experimental studies. In this case, we do not have an independent variable. So to sum up this lecture, Power is a probability of obtaining an effect if it exists in reality. The p-value is a probability of finding an effect assuming that your null hypothesis is true. Statistical significance shows that you indeed found such an effect. And an effect size is a measure of the magnitude of this effect. And that concludes today's lecture on power and precision. I hope you enjoyed it and see you again next time.